Good morning, Professor.
Hello, hello.
I had a quick question for you before we start off today.
Good. Go ahead.
So on Thursday, we were talking, you said from now on we could use test benches or the VWF file, the waveform file, to show that our code worked from now on.
No,
But
I said you have the option to use test bench or waveform generator.
yeah, so we have the option to use either, but the second homework asks us to make test benches. Do we need to?
No. Just
Okay.
as I said, you can use either one, whatever you
Okay,
like.
so if I turn in the homework with the VWF files, I'm fine.
No problem. Yes, of course, you
Okay.
can.
I just wanted to make sure. Thank you.
Thank you. Hello, Paul.
Hello.
How are you today?
Oh, doing pretty well.
Enjoying the weekend?
So far, yeah.
You have great plans?
I have a 5-month-old daughter, so just kind of hanging out with her and watching her grow.
Oh, great.
Yep.
Okay, you are going out?
No, probably just staying in all weekend.
Okay. Eric?
Good morning, sir.
Hello. Are you ready to start?
Sure.
Okay. Let's go for our third topic. In this third topic, we are emphasizing the use of our FPGA. And today we are not going to use test bench. We are not going to use the waveform generator. We are going to use real input and serial output of the FPGA. I believe some of you did that on our last quiz. That was great. But if you haven't, I accepted it. But for today assignment, our lab, we're going to use this FPGA input output. So we're going to be downloading the program to FPGA and giving it input through the input switches and see the output on the LEDs. We spoke about homework 2, and I believe we finished it all last time. And today we are going to speak about our Max 10 device. What is it? You are going to see on it those numbers. What do they mean? For example,
are you sharing your screen?
Oh, yeah. I haven't, sorry. This is the code associated with our device. The 10M means 10M, this is Max 10 family. 16, this says the memory card on this, it is 16 kilobyte. DA, this one, it means dual supply, as you can see it here, dual supply analog features. And the U, this is the package type, ultra fine line. This is how it is manufactured. This is the 484. I believe those are the number of pins that we have on our device, the packaging, 484. 484 pins, 23 millimeter by 23 millimeter. this is the operating temperature, recommended operating temperature from -40 to 100 degrees centigrade. 7, this is the speed of the processor. We have 7, it is moderate. And then we have the last letter G. This is operational suffix, indicates specific device options on shipment. This is not engineering sample, this is G. And this is the board you have. What do we have in it on it? Of course, this is the Altera Max 10. This is my brain. This is my static RAM here. And I have here the 5-volt power USB blaster. This is my USB connection. Got connected here. And what do I have here? The VGA connectors. I have here buttons, 2 buttons. I can use them as input. I have here 10 LEDs, light emitting diodes, those for outputs. And I have also 10 switches. 10 switches. I can use all 10 as input. I have also 7 segment display. I have 6 of those. Oh yes, I have here also accelerometer. I can use it. And this is a very important, this is a 2x20 general purpose input output. I can connect here 40 input output. Now let's go little by little and see what do we have. We have here 4 LEDs. 1, 2, 3, 4. The first one, Eric,
Yes.
would you please read the first one?
D1 is ULED and it illuminates when the onboard USB blaster is working.
Can you see it on your own board?
Yes, I can.
Okay.
It says load, yeah, D1 load.
Okay, thank you. Kobe,
Oh, yeah.
would you please read the second one?
Yeah. So D2 conf done illuminates when the FPGA is successfully configured.
Okay. Thank you very much. Taylor?
Hi.
D3 and D4?
D3 lets you know if power's on.
Okay.
D4 is the power good when the system is okay, power system.
Okay, so we have testing. If it is tested good, we can proceed. Okay, thank you.
I noticed my board D3 is not on the board. It's not soldered on the board. It's missing.
It says
Oh.
not installed in the description.
Oh, not installed. Thanks.
Okay. We have also clock sources, and here we have analog to digital clock. This is 10 megahertz. We have Max 10 clock 1. This is 50 megahertz. And another clock that is also 50 megahertz. And we can access those through those pins. Pin N5, pin P11, pin N14 if you want to use those clocks. What do we have also here? As we said, here we have two push buttons. Two push buttons. Those two push buttons hello, Paul.
Hello.
This key 0, if it is open as it is, the board B8, the input B8, will it be high or low?
Low.
If key 0 is open as it is in the figure. Will it be low or high?
High.
Oh, okay, because it doesn't have a path to ground. So yeah, it'll be high.
Yes, it will be high because it has the power here, VCC, going through the resistor to the input.
Okay.
When I hit this, it will be connected to ground, so it will be 0.
Understood.
So again, to use those push buttons, I need to use their address. Okay. Now we have slide switches. Slide switches, where are those? Here. Those slide switches, I can use any one of those, and I need just to address them by this FPGA pin number. Again, this is logic 1 and logic 0. So any one of them, I can use them as input to my FPGA. And here we have the light emitting diode. Light emitting diode. We have again 10 of those, and those are the pin numbers for those 10 LEDs. LED 0 up to LED 9. The general purpose input output, we said 2 times 20 on both sides. So we have those, and we have, of course, the pin number and how to use them. This is a detailed description of the 40 general purpose input output. It can work as input, it can work as output. This lab 2A, would you please open it? In this lab 2.8, what we have here, it is instruction and step-by-step how we can make. This is starting as any other program we started, and we are building a full adder. And this is the code for full adder. And after entering the code, this is how I can assign 2 inputs the full adder, and I can assign an output. So my inputs will be X, Y, and carry in. My output will be sum and C out. So I will use B14, A14, and F15. Those will be my three inputs, X, Y, C in. And my output, C out, will be A9, and summation will be A8. Hello, Trevor? Trevor?
Hello.
Would you please, we are gonna speak about adding numbers. So we have X and Y and C in, and my output will be summation and carry out. If I have 0 input and 1 and carry in 1, what will be the summation of this and the carry out?
Would summation be
I have 0,
yeah,
0, 1, 1.
so then summation would be a 1 or a 2?
What is 2 in binary?
1 0
No, 0, 1.
0 1
So the summation will be,
0 1.
no, the summation is 1 bit.
Okay.
I have summation and carry. What will be the summation?
0 and then C out would be 1.
0 and the carry will be 1.
Yeah.
Thank you. Joe?
Yeah. Hi.
If I have here 1, 1, 1, what will be the summation and the carry?
Be a 1 and 1.
1, 1, 1. What will be sum and carry?
Well, the sum would be a 1 and the carry would be a 1.
Excellent. Because here we have 3. And 3 in binary is 1, 1. Excellent. Thank you. I am telling you this because you need to verify your answer. You are going to give inputs and you are going to see the output. So you need to know what you are giving and what do you expect to see on the light emitting diode of sum and carry out. Then after doing the programming side and doing the compilation, now I am ready to check it. I can check it with the Wave4 VWF universal program. We can do it. So we do it and make sure it is running. But after you are satisfied with its running, this is the same steps used over and over. Now we'll be ready to download this program to our board. After running it on the waveform and being satisfied with it, now I can download it to the board. And here you are going to see the instruction on how to download it to the board. By default, it should download, it should be whenever you connect your system to the USB port on your laptop or computer, it should be detected and it is, the driver will be installed. But if you have trouble, I sent you an announcement. This announcement has a link. Just if you have trouble using or detecting the driver and installing it automatically, you may use this to download the driver. Any questions? Any questions? Okay.
I'm
I'll
pretty
give,
sure.
yes.
Sorry.
Go ahead.
Whenever I was dealing with the driver issue, I think I was able to find the driver. It was already on my computer.
Yeah,
And so you just have to go into Device Manager and point it to install the driver from wherever it is held on your computer, which I think was just like the C drive, Altera Lite 16.0, and then Cortus drivers. I think that's it. So C Altera Lite 16 Cortus drivers, if anyone needs it.
would you please share the screen?
Yeah.
Okay.
I'll share this one. So, can you see?
No.
No. Can you see now?
Yes.
Okay, so you go C Altera Lite 16.0 Cortus drivers. And then I think it's this one, X64. I think that's the file that you point it, the folder you point it toward.
Yeah.
And then it'll install from there.
Okay, great.
Okay.
So please go ahead and do this full adder. If you have it already, okay, go ahead and download it. If it is running, you may just download it to, of course, you need to specify the I/O ports and then download it and test it. Okay. Go ahead, I'll be around. If you need any help, we'll give it maybe 45 minutes to do this. Thank you all. In this homework, we have this circuit. And in this circuit, as you can see, I have input X and input clock and one output. This is clock and this is X. And you are supposed to find out what will be the output. To find out the output, this out, I need to find first, given X and Y, X and clock, what will be Y, this Y? What will it be? And given this Y and this clock, what will be Z? Again, given Y and clock, what will be C out? Please note Z is a D flip-flop. But to get C out, it's a counter. A counter, it is incrementing with each clock as long as the chip enable is high, as long as Y is high. The output of the counter is C out. This is a 3-bit. C out is a 3-bit. And this C out, the 3-bit, it goes through adder. So adding what? Adding 3 out, a C out, and I'm taking feedback here, out. Those two are added, and those are called out. Again, 3-bit going to a D flip-flop. In a D flip-flop, I need chip enable coming from Z and a clock. Let's go step by step. Here, if I have, this is my clock and this is my X. What will be Y? Joe? Hello, Joe?
Yeah, sorry, where were you at? Where, point the mouse? At the first clock, the Y
At the
will
first
be,
rising of the clock.
the Y will be a 0.
No, at this edge, what will I have?
Should have a 0.
Just a moment.
Because the X hasn't set up yet.
You mean here for the first clock, Y will be 0?
Yeah, because the X hasn't had the setup time yet. So the first clock, the Y will be
Yes,
0.
excellent. X needs a setup time. X should exist before the rising edge. But since before the rising edge, we had no X, or X went up on the same time as the clock, so it will miss the clock. Okay. So I will put here 0. What about the second edge, the second rising edge? Taylor?
Y would be high.
It would be high because, again, we can imagine X extended a little bit. So it was here before the rising edge of the second. Yes, it will be high. As you can see, I shifted myself a few micrometers. What about the third rising edge? Cody? Third rising edge, what will happen?
It'll be low.
It will be low, yes, because it has been low for a long time before it, and it didn't catch this rising in here. This is extra. Now, Daniel, fourth rising edge.
It'll be high again.
Of course. And fifth rising edge.
Also high.
Okay. Sixth rising edge.
it'll go low.
6 rising edge. Okay, so we'll go high. I believe you can continue with this in this manner. And of course, here you need to think about Z. Z is taking D, it's the input, it's Y, and it has a clock. I believe this is very, very challenging, and this will be our homework, and this can be uploaded. And I'm gonna give you the time right now to work on homework and finish this lab 2A part. And if you have any questions, I'm available. If you do not have any question and you wanna leave, you are free to leave.
So for the lab, we're just submitting the 2A,
No,
not
you
the
are not
2B.
submitting lab now at all. Lab
Got it.
2A and B must be submitted together. It is one grade. I'm grading lab 2, A and B. Okay, so we'll wait until I go over it on Tuesday. If we finish it, that would be great. If not, I'm going to extend the submission time. But lab 2B, it is about something called state machine, and I have to speak about it in our lecture.
And then
questions?
just to clarify, homework 2 is submission needs to be done by tomorrow. Or turn it in earlier.
Let me see.
That's what it says on my end for the submission date is tomorrow.
Okay, just a moment. Homework 2, it is this homework we are working on right now. Oh, homework 2, yes. Yes, no problem. We had homework 2, haven't we did it?
Yeah.
Okay, we have done it already. So
Yeah.
you can submit it.
Okay, great. Thank you.
And homework 3, you have up to next week.
Are we gonna circle back to?
And lab 2 is up to February 18.
Are we just focusing on the handwritten portion of homework 3 today, or are you?
Yes, please try to finish it while we are not if you finish it and you want to submit it, okay, submit it, no problem.
Okay, but it also says to do a VHDL code to implement the circuit. So are we going to go over that at all, or are we just moving on?
I think if this VHDL, it is just to verify that what you did is correct. What you did by hand is correct.
Okay.
But VHDL code, you know how to build a D, flip-flop, counter, adder. All of those, we did it. You just assemble it together to verify that the waveform you did by hand is correct.
And you could even do a test bench from component from schematic to get the VHDL code.
Yes,
Okay.
with the from schematic you can convert to VHDL code.
Yeah.
I sent you the instruction in one of the assignment. You have the instruction. Do you know where to get it? When we spoke about test bench, I gave you a
video.
PDF file,
Yeah.
and I did it in my video, I believe. Anyone want to share your screen? You are welcome. If you have any questions, I am available. Okay, thank you.
So I'm still having some problems with connecting my FPGA. I can't get it to compile onto my board, and every time I try to start it, it's just saying failed. I went through the process of trying to update the driver, but nothing has changed since.
I don't know if I can be any help, but I can give it a shot if you want to stream or share.
Yeah, I have to connect with my laptop first.
Are you on Windows 10, 7, or 11?
11.
11. Okay, different than mine, so I don't know if I'll be any help.
Okay.
Do you mean that the driver is old for this version of Windows or what?
Well, it's showing the right chip at least.
Is this the right chip?
Yeah, so you see where it has the picture of the Intel chip? I was just
Yeah.
putting the name right under it.
Oh, there we go.
Oh, great.
Thank you so much.
Have you assigned the pin numbers?
Yeah.
They kept their assignment through switching it.
Oh, gotcha, gotcha.
I don't know if it does or not. I'm just curious. It's something to check.
Yeah, I'll probably check that.
The pin number assignment. Now we are ready. Working?
It's definitely loaded onto my board. There must be something wrong with my code because it's not, the switches aren't doing anything to the LEDs.
So
Have you
I'm
tried
just-
the waveform file?
I'll check that and see if it's working.
Okay.
On my board, it's just the left three most switches and the two rightmost LEDs that are used.
Oh, that's why I was using the right switches. It's working.
Okay.
No matter what I try, I can't get my driver updated, so I'm kind of stuck in the water.
Did you already grab the one from GitHub?
Yeah, I tried that one.
Don't know if I can help, but do you want to show your device manager?
Sure, yeah. Any help would be appreciated. Let's see.
Why not? Spitballing has worked so far today.
Yeah. Okay.
Yeah. Go ahead and, yeah, redo that. Browse. Okay, it looks like you have the same issue I did, so scroll down until you get to where that is. Choose USB blaster instead of the by 64.
Oh,
That file, now run it.
oh,
I did the
Okay.
exact same thing. Somebody fixed it for me earlier.
oh, awesome. I was banging my head against the desk. Cool, thanks. Okay, everything's working. Thanks again.
No problem.
News, great. Hello, Bart? Bart, are you
Yes.
available? How is it going?
What's that?
How is it going?
Oh, we're still, I'm sorry, I was working on the project. I wasn't paying attention. It's going good. I was a little bit slow on getting things going, but I just got my FPGA to work, the lights work and stuff. I haven't started the homework yet.
Okay, okay, okay. Do you need any help?
No, but it worked fine. I got the drivers to go through and everything was A-okay. I
Okay,
think the
sir.
homework, I just spent some time on that. I think it'll be all right.
Okay, great. Thank you.
Yep, thank
I
you.
just got my FPGA working too.
Okay, so the FPGA, this is the most important thing. And I believe you can work with the homework assignment and slowly you will get it. And if you have any questions, I'll be available, of course, Tuesday. We can discuss it more and more.
All right, sounds good. Have a good day.
Okay, you too. Bye now. Thank you.